Okay, welcome to another video. Today we're going to be looking at what's called the Argand plane, and we'll finally talk about why we say that the complex number a plus bi is in Cartesian form. Okay, so recall the definition of a complex number. In set roster notation, it was that the complex numbers are the set a plus bi, where a and b are real numbers, and I is the imaginary unit. I squared is equal to -1. Okay, and we can therefore say that z, any complex number z, is just made up of two parts, a and b. A is the real part, b is the imaginary part. And remember, they're both real numbers. Okay, and therefore we can represent them as what's called an ordered pair, where a is going to be the first component, b is going to be the second component. In this case, it's going to be the real part and the imaginary part. And you can already see that's starting to look like coordinates on a graph. And a graph, in maths, we call that a Cartesian plane. Okay, so that's where this idea of calling it Cartesian form comes from, because a complex number written as a plus bi is just made up of a real part and imaginary part, and that pair, we can graph it on a normal Cartesian plane. But in this case, we give that Cartesian a special name called the Argand plane. Okay? And this is how we form it. So in a normal graph, we have, called a normal graph Cartesian plane, we have an x-axis and a y-axis. We're going to rename the x-axis the real axis, or REZ, and we're going to call the y-axis the imaginary axis, or IMZ. Z is just the complex number that we're going to be talking about, we're going to be plotting. Okay, now that we've done that, now that we've renamed those axes, this is called an Argand plane. And it's for plotting complex numbers, but it behaves just like a normal Cartesian plane, just like a normal, as if we were plotting normal points. It's just those points are going to be complex numbers. Okay, so the complex number z equals a plus bi, I just plot that as the point AB. A is the x-axis, the real axis, and b is the y-axis, the imaginary axis. Okay, so if I wanted to plot that complex number, that's what it would look like, just be the point AB. Okay, and as I said, we give this Cartesian plane a special name called the Argand plane. So here's some examples. If I talk about the first complex number here, z1, it's 1 plus I. The real part's 1, the imaginary part's 1, so I plot the point 1, 1. Okay, there it is. That second point, the second complex number, 3 plus 2i. Real part's 3, imaginary part's 2, so I'd plot the point 3, 2. Z3 is important because this is just like in year 7 when you were going back and learning how to plot points on a graph. 3 plus 2i is not the same number as 2 plus 3i. It has a different, and just like back when you're plotting points, it's a different point on the graph. Okay, so 2 plus 3i has real part 2, imaginary part 3, so it's the point 2, 3. So they are distinct numbers and they have different points. Okay, and we can work with negatives just like we normally can. If I've got z4 is -2 plus 2i, that's the point -2, 2, which is over here. Okay, and then I can easily put z5 and z6 on the graph here as well. Okay, so it's very easy to plot points on the Argand plane. Pretty straightforward. But it's going to be an extremely useful tool, as you'll see when we get to more complicated work. So that's all we needed for the Argand plane. Nice short video.